Hello, welcome to the short video over scientific notation. This video is going to go over how to express numbers in scientific and standard notation, how to compare numbers when they're written in scientific or standard notation, and then choose the appropriate level of accuracy. So scientific notation, basically what it is a lot of mathematicians and scientists use it to express numbers that are either really large or really small in this shorthand form of using powers of 10. So the correct form is a times 10 to the n, where a is between 1 and 10 and n is an integer. Down here you'll see I included the definition from your book, which has a few examples. So we have 8.3 times 10 to the 5. 8.3 is between 1 and 10, and that 5 is an integer. Remember, an integer is a whole number, either positive or negative. So 4.12 times 10 to the 22nd. 7.1 times 10 to the negative 5. So let's kind of discuss the how to go back and forth between standard notation and then scientific notation. So scientific notation is the number is either written really large or really big, and we're going to change it to be in that power of 10. So if we have the number here, 213 million, we want to write that in scientific notation. That's a lot of zeros. So what you kind of do is, wherever your decimal is, we then need to change this number to be between 1 and 10. So I'm going to put it right here between the 2 and the 1. I'm not going to put it between the 1 and the 3 because that would give me 21. So, and then I'm going to kind of just count. Okay, how far did I move? 1, 2, 3, 4, 5, 6, 7, 8. So I know my exponent is going to be 8. So I would write this as 2.13 times 10 to the 8. My exponent is positive when I am taking a really large number and writing it in scientific notation. If you look at the next example, I have a small number that I'm changing to scientific notation. So again, the first thing I want to do is put my decimal in the place where it's going to make my a between 1 and 10. So in this case, it's between the 8 and the 7. And then I'm going to count how many place values I am moving that decimal. So in this place, it's 3. Because I am moving to the right, or I'm making a small number, I'm writing it in scientific notation, you'll notice my exponent is negative. So it's 8.72 times 10 to the negative 3. Now let's go the other way. Let's say we're given scientific notation and we want to go in standard form, or in this case, another word for it is expanded form. So I'm taking 5.6 because my exponent is positive. I know my value is going to be large. So I know I'm going to move my decimal place from, I'm going to write the number down here so I can write here. So 5.6, I'm going to make a big number. It's going to be large, so I'm going to move that decimal place to the right. 1, 2, 3, 4 places. And I'm kind of just going to fill in those spots with zeros. And again, going the other way. So 9.71 times 10 to the negative 5. So this time I'm moving my decimal place to the left because my exponent there is negative. So here, let me go ahead and write this, 9.71. And I'm moving it to the left 5 place values. So here's 1, 2, 3, 4, 5. And again, every place value that doesn't already have a value, I'm just going to fill in with zeros there and make sure to put my decimal place. So let's express 0.000000902 in scientific notation. So you can see right there, there's a pretty small number. And the reason we would probably want to write it in scientific notation is that's a lot of zeros. We could mess that up pretty easily if we're using this number over and over again in like a science experiment or whatever the case may be. So the first thing you would do is determine, okay, how do I make my value, my a, between 1 and 10? So in this case, my place value needs to go between the 9 and the 0. If I put it here at like 0.9, I would have gone too far. That's not between 1 and 0, or 1 and 10, excuse me. Next then, how many place values did I move it? Well, let's see. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8. 8, so when I write this, it's going to be 9.02 times 10, and my exponent is negative because remember I have a small number that I'm writing in scientific notation, so I know it's going to be a negative exponent. So again, going the other way, if I have express 1.8 times 10 to the negative 4 in standard notation, so this time I'm going from scientific notation and I want to put it in that expanded form. First off, because I have a negative exponent here, I know my value is going to be small, and I'm moving my decimal to the left. I'm moving it to the left 4 places because it's negative 4. So that would give me 0.0018. All right. A common thing we also do with numbers in scientific notation is we order them from least to greatest. Let's say, we're measuring the size of a bunch of insects, and we want to order the insects from least to greatest. So just, random example out there. But anyway, so here's how we're going to do it. We're going to list the numbers in order by the powers of 10. So step 1. So all we're doing to begin with is just pay attention to that 10 and that exponent. So I'm going to write these from least to greatest because that's what this problem says. It says from least to greatest. So from smallest to biggest. So smallest between -2, 3, a -2 and a -3 would be -3. So I'm going to move 5.4 times 10 to the -3. And then I'm going to list my 2 values that have the exponent of -2. And lastly, my exponent of 3 there at the end. The second step then is order the numbers that have the same power. So in this case, my 2 values that had the same power were this 1.3 and that 1. So I would just have to make sure, okay, is 1.3 or 1, they go in order from least to greatest. Well, 1 is obviously smaller than 1.3. So in this case, I needed to switch these in order for it to be in the correct order. So now these values are listed from least to greatest. Lastly, this lesson talks about is accuracy versus precision. So accuracy is basically the number is correct. It's accurate. Precision, or if a number is precise, the number is more exact and has more digits. You're probably thinking, okay, so let's kind of look at an example. An accurate age of Chloe Kim. I don't know about you, I love the Olympics, so I'm using the gold medal winner for the snowboard. She was 17 years old when she won gold. However, a precise age for Chloe Kim would be 17 years and 297 days. So when someone asks you how old they are, you don't say, oh, I'm, 15 and 32 days. We don't say that. We just say we're 15. So the 15 is still accurate, but a more precise value would be your 15, or what did I say? 14 and 32 days, 15, 32, I don't know, whatever I said. But hopefully that makes sense. So accurate is correct. It's usually just maybe like rounded up or down, where precision, the precise number, is that exact value. So hopefully this kind of helped with the scientific notation lesson. If you have questions or need any help, don't hesitate to reach out to your teacher.